Mushi mushi. Hola hola. Hello hello. Assalamualaikum. Hello everyone. Our topic is about one sample and two sample proportion. For the one sample proportion means that there is only one set of data that being used. And for the two sample proportion means that there is two set of data that being used.
For us to have an in-depth knowledge regarding the one and two sample proportion, let's go to the library. Come on, guys!
Hello! So our problem number 1 for the one sample proportion, the records of patients in the hospital shows that 35 of 100 patients have a high cholesterol level of 214 milligrams per dl and above. Can we conclude that 30% of the patients have high cholesterol level? Use a one-tailed test with alpha equals to 5%. So we have the given x is equal to 35 and equals to 100. And before we get the p hat, we have to use the formula x over n. So we have 35 divided by 100 is equal to 0.35. For the p, we have the 0.3. Where did we get the 0.3? We get the 0.3 from the 30% in the problem. And so for the q, we have to use the formula 1 minus p. So 1 minus 0.3 is equals to 0.7.
We have our first problem. So to come up with the correct answer and correct conclusion, let us follow our step-by-step process. And for our first step, we will going to determine our null hypothesis and alternative hypothesis. So according to problem, our null hypothesis is there is no significant difference between the population and the sample proportion, and that is p is equals to p hat. So now we will going to determine our alternative hypothesis, which contradict our null hypothesis. So our alternative hypothesis is the population proportion is higher than the sample proportion, and that is p is greater than p hat, and that is our claim.
Step 2. We use the z-test with alpha a equals to 0.5%, and remember, according to our problem, it is a one-tailed test.
For the step 3, using alpha 0.5%, and remember, it is one-tailed test, so we have the critical value 1.645.
Step 4. We will compute for the z value. And for one sample proportion, we have the formula. For our first example, for one sample proportion, we will substitute the given. It is 0.35 minus 0.3 all over square root of 0.3 times 0.7 divided by 100. So we will get 1.09.
Since z is less than c, meaning we should accept the null hypothesis. Conclusion. The absolute value of 1.09 is less than the tabular value of 1.645, meaning we should accept the null hypothesis and reject the alternative hypothesis. And there is no significant difference between the population and the sample proportion.
So we have the problem number 2 for one sample proportion. The results of exam in the statistics and probability shows that 16 out of 35 students passed the exam. Can we conclude that the 45% of the students passed the exam using two-tailed test with alpha? So we have the given x is equals to 16 and n equals to 35. So as we get the p hat, we have to use the formula x over n. So 16 16 divided by 35 is equals to 0.45, 71, 42, 85, 71. So as we round it off, we have 0.46. For P, we have 0.45. And for our Q, we have the formula 1 minus P. So, as we get the Q hat, we have to use the 1 minus P hat.
Step 2. We use the z-test with alpha A equals to. And remember, according to our problem, it is a two-tailed test.
Step 3, using alpha percent. And remember, it is two-tailed test, so we have the critical value positive negative 2.575.
Step 4. We will compute for the z value. And for one sample proportion, we have the formula. For our second example, for one sample proportion, we will substitute the given. It is 0.46 minus 0.45 all over square root of 0.45 times 0.55 divided by. So we have 0.118917.678 or 0.12.
Since Z is less than C, we should accept the null hypothesis. So the conclusion is, the absolute value of 0.118917678 is lesser than the tabular value of 2.575. Therefore, we should accept the null hypothesis and reject the alternative hypothesis, meaning there is no significant difference between the population and the sample proportion.
In our problem number 2 for the two-sample proportion. In the study on the effect of cigarette smoking to human health, it was found out that 35 among 55 cigarette smokers aged 40 years old and above suffer from cigarette-related diseases, and 28 among 15 smokers aged below 40 years old suffer from the same diseases. Is it safe to conclude that the proportion of smokers aged 40 years old and above is significantly higher than the proportion of smokers aged below 40 years old who suffer from the related diseases? Test the hypothesis at alpha equals to 0.01. So we have the given for the age 40 years old and above. For x sub 1, we have 35. For n sub 1, we have 55. And for the p hat, we have the formula x over n. So 35 divided by 55 is equal to 0.64. And for the age below 40 years old, x sub 2 is equal to 28 and n sub 2 is equal to 50. And for the p hat, we have the formula x over n. So 28 divided by 50 is equal to 0.50. So for the p, we have to use the formula x sub 1 plus x sub 2 over n sub 1 plus n sub 2. So 35 plus 28 over 50 plus 50 is equal to 0.6. And for the q, we have to use the formula 1 minus p. So 1 minus 0.6 is equals to 0.4.
Step 2. We use the z-test with alpha equal to 0.01%. And remember, according to our problem for two sample proportion, it is a one-tailed test.
For the step 3, using alpha 0.01%, and remember, it is one-tailed test, so we have the critical value 2.33.
Step 4. We will compute for the z value. And for our two sample proportion, we have the formula z is equal to p hat sub 1 minus p hat sub 2 all over square root of p times q quantity 1 over n sub 1 plus 1 over n sub 2 quantity. Where n sub 1 is the sample size of the first sample, x sub 1 is the number of successes in the first sample, and p hat sub 1 is the proportion of the number of successes to the number of samples in the second sample. And n sub 2 is the sample size of the second sample. X sub 2 is the number of successes in the second sample. And P hat sub 2 is the proportion of the number of successes to the number of samples in the second sample. For our example, for the two sample proportion, we will substitute the given. So it is 0.64 minus 0.56 all over square root of 0.6 times 0.4, quantity 1 over 55 plus 1 over 50. So we have 0.8357.
For the conclusion, the computed z-value is less than the critical value, meaning we should accept the null hypothesis. The absolute computed value of 0.8357 is less than the critical value of 2.33, meaning we should accept the null hypothesis. Hence, the proportion of the smokers age 40 up does not significantly differ from the proportion of the smokers age 40 below.